We're going to use this position vector. So always think about what you were given, because you have position, velocity, and acceleration. And so you want to think about what the thing they gave you was. They gave us position. It says find the velocity vector, the acceleration vector, and an expression for speed. All right, so let's go ahead and find our velocity vector. How do you get from position to velocity? Derivative. Okay, again, it's not really new material. Okay. Now, if you do the derivative of 2 sine of whatever, you're going to get 2 cosine of whatever. But there is a chain rule, and you have to chain on the derivative of 1/2 t, which would be 1/2. So the 1/2 and the 2 are going to cancel out. Okay, good. So it is cosine of 1/2 t. And I prefer writing it as 1/2 t instead of t over 2. You're welcome to like it the other way. It's not, there's no one is right and no one's wrong. I just like it with a coefficient and then a variable. All right, comma. Now we're going to do the same thing with this one. Derivative of cosine is negative sine. Again, there's a chain rule. The 2 and the 1/2 are going to cancel. So negative sine 1/2 t. So that is our velocity vector. How do you get from velocity to acceleration? Well, we're going to do another derivative. So do it again. So now this one, derivative of cosine is negative sine, but you're going to have to chain on the 1/2. So we're going to get negative 1/2 sine 1/2 t, comma. Every time you do a derivative, there's another chain rule in there. It's just because there was a 2 and there was a 1/2. They canceled, but then that didn't happen when we went this second derivative. And then derivative of sine is cosine. That negative just sort of happens to be there. It's going to be negative 1/2, good, cosine 1/2 t. And then speed. So great big square root. And I would leave it blank. You're going to have something squared plus something squared. And remember, the conversation we had about it was we don't use an absolute value, but the other way to turn something positive is to square it, and then you square root it to get back to where you went. Yes, and velocity is what goes in there. So this cosine 1/2 t goes here, and then negative sine 1/2 t goes there. So we're turning it positive to make it be speed instead of velocity. All right, is the particle speeding up or slowing down at time 0? So think back to particle motion that we did before. You had to look at both velocity and acceleration. Same sign means speeding up, opposite signs slowing. It's very similar, all right? So we're going to get our velocity vector at 0. We're going to get our acceleration vector at t equals 0. And see what directions they're pointing. If they point the same direction, speeding up, opposite direction, slowing down, or if they're a right angle, then speed is constant.
For speed, does it really matter if we put a negative or not?
So in that case, it doesn't. I would put it, though, just to be thorough. Like if on the AP exam they said write an expression for speed, I would put it. But you're right. When you square a negative, it's going to turn positive. But just for the sake of being thorough, I would put it. But yes, you are correct. All right, so let's plug 0 in here. Think about your unit circle. Where is 0 pi? Up, down, left, or right?
Right.
To the right, it's the coordinate point 1, 0. Cool, 1, 0. Cosine is what part of that? The x, so 1. So that's going to be 1. And then sine of 0 is 0. Yeah, I will draw it for you if that is helpful to us. There you go. Did you see how long it took me to draw that? It's just a margin problem. You just write it off to the side. I know, I'm not trying to brag, but I can draw a circle pretty quick. All right, now we're going to do acceleration. Same thing. We're going to plug in 0 or 0 pi. I like when we put the pi next to it, 0 pi. All right, so acceleration. Sine of 0 is 0 times negative 1/2 is still 0. Cosine of 0 is 1 times negative 1/2 is negative 1/2. Now, if you can hold this in your mind, that's totally fine. I'm going to draw a picture, again, just like a margin problem here. If you have a vector that has an x component of 1 and y component of 0, it's going to go 1 in the x direction, nothing in the y direction. So it's going to look like that. And then for your acceleration vector, same thing, but you have 0 for x, negative 1/2 for y, so it's going to look like that. So what do you think? Like, what do you think for our answer? Because we're going to... Yeah, so we're going to say speeding up or slowing down, we would say neither at t equals 0 because speed is constant. You could write something about them being 90 degrees, but speed is constant is more succinct. They'll take that answer, and so that's what I would. You have to put the at t equals 0, though, or they won't give it to you. You always have to say at what time you're talking about. Yep, that's it. That's done for that one. All right, number 2. What did they give us this time? Velocity. Okay, so just be aware of what they gave you. Okay, this time it's velocity. When t equals 0, particle is at the point 21. What do we call that? Initial condition, all right? And it's when t equals 0, so that's convenient. Where is the particle at t equals 2? All right, we're going to do x first. You have to do them separately. Where did x start? What is our x? 2. Do you see that right there? 2. Plus, we want to integrate from 0 to 2 of your velocity vector, which is 2 dt. I'm writing it all out even though it's just 2, because say it was more complicated than that. This is the process of the problem, okay? So what is your antiderivative of just 2? Well, it would be 2t such that 0 to 2, and then you do upper minus lower. Also, what if the lower boundary wasn't 0? You know, what if we started at -6? That can happen. You know, sometimes they'll do that. All right, so upper minus lower would be 4 minus 0, and so we get 6. So yes, I realize it was just 2 plus 2. Or no, 2 plus 4. But again, sometimes the problem will be more complicated, and so it's still good to know the process. Let's set it up the exact same way for y. What was our initial condition for y? 1 plus integral where to where? 0 to 2. And then your velocity for y is 4. And we're just going to go through and do the exact same process with different numbers in it. So 1 plus 4t such that 0 to 2. And you're going to do upper minus lower, which would be 8 minus 0. And so 9. So your coordinate at t equals 2 is 6, 9. So you do each dimension separately, the x dimension and the y dimension. Not hearing anything, so is that okay? That went over easy? Okay. You've done it before. We just now have an x and a y, okay? Total distance. Oh, go ahead. Oh, there's a question.
So, how can we use, when should we use the different brackets?
So, and I actually messed one up later on where I used the wrong one, so I'm going to have to bring that up. If it's a vector, you want the pointy ones.
Yeah.
So if it's a position vector, you want the pointy ones. And if it is like an initial condition, like where the particle is at that moment in time, then that is a coordinate point. Okay. All right, total distance from 0 to 2. So we're going to go 0 to 2, and then what goes in there? I know some of you got out your little formula sheet we had from last time. Well, not velocity, but for total distance, we want speed. So it's that whole square root thing, okay? Yeah, prime. It's velocity. Speed is absolute value of velocity. It's just we don't absolute value it. We square it and we square root it, blah, blah, blah. Anyway, what was the x dimension for our velocity vector? It was way back when. That part's 2, and then y is 4. We're going to work this out by hand. It's not that hard. They're both constant, so. 2 squared plus 4 squared. What is that? 4 plus 16, so 20. Now, I realize that looks funny because it's a square root, but square root of 20 is just a number. Pretend it's just 20. You know what I mean? Like, or pretend it's 7, or pretend it's 3. Like, it's just a value, right? So what's your antiderivative? Yeah, square root of 20, t. It's just that number with t after it. Yeah, so just, I know it looks funny, but just pretend it's a number, because it is. And then you do upper minus lower, and so your final answer is 2 square root of 20. I'm perfectly fine with that answer. However, just for the sake of being thorough, if on the AP exam they reduced the radical, do you remember how to do that? Like yeah, so 20 would break into 4 times 5. Square root of 4 is 2. And so they might write the answer as 4 square root of 5. Again, I don't want you to get here and then not be able to like pick your answer. Do you know what I'm saying? Like that's a sad day because all your calculus is correct. And then if you can't get the answer because you can't, reduce a root. All right, find the position vector. Use R for position, which doesn't make any sense. We kind of already did it. All right. You take your initial condition, which what was it for X? It was 2. We're going to do them one at a time. So for X, it's 2. And then the velocity for that also 2. And so when we did our antiderivative, it was 2 plus 2t, comma. And then look back at the work we did for Y. You take your initial condition plus, and then that integral. So it would be 1 plus 4t. Good. We kind of already did it, so I'm not writing it all out again. Hooray. Do you need a brain break or can we keep going? You want a brain break? Okay. Take like a 2-minute break. Okay. Eyes up here. So what did they give us for this one? Position. Okay, just be aware of what they gave you. We want when, so t equals something is going to be our answer. Is speed a minimum? All right, first we're going to have to get an equation for speed, and it's going to be this big old square root, and I would draw it out blank first. We'll get to the minimum part in a second, but we want speed. When speed is a minimum, you need an equation for speed. Now, position is not what goes in there. What goes in those blanks? The velocity. So we're going to have to derive. So the first part for x is just t. So the derivative of that is 1. And then this one, if you do the derivative, you're going to get negative 6 plus 2t. Can I write that the other way around? Is that okay? 2t minus 6. You know, I meant for that to come out different, though. Hold on a second. All right. Now, as a heads up, we're going to have to do a little bit of algebra here. Okay, so we might need to do a margin problem. 1 squared is just 1. But when you go to do 2t minus 6 squared, this is what that means. And if you can do it in your head, that's cool. If you want to write it out, fine. Like, do whatever works for you. All right, we're going to just distribute all this stuff together. So 2t times 2t, 4t squared. I love when everybody can just come with me on. It's great. Now, if you multiply the outsides, that gives you negative 12t. The insides gives you negative 12t. So negative 24t. Do you understand where the negative 12 came from? 2 times 6? Okay, cool. And then negative 6 times negative 6 is 36. Cool. Now, the only thing you can do to combine like terms there is the plus 1 and the plus 36. Cool. So we found an expression for speed, go us. Now, we want when speed is a minimum. So this is way back. Maximums and minimums come from what? Oh, who are your candidates? Start and end point, which we don't have here. It's just the whole number line. And who else are your candidates? Critical points. How do you get a critical point? Derivative equals 0. So we're going to find speed prime and set it equal to 0. We're going to get the derivative and set it equal to 0. Cool, we got there, all right? How do you do a derivative of square root? 1 over 2 square root, okay? I told you to just memorize that one because it's a lot easier if you just know it. If you're panicking, don't. This actually won't turn out as bad as it looks like, okay? I know it really does, but it won't be as bad as you think, I promise. So it's 1 over 2 square root of whatever. I didn't put the 1 because what do I actually need to put? It's the chain rule. So you chain on the derivative of that inside stuff, which would be 8t minus 24. And we're going to set this equal to 0. you get to ignore the entire denominator, because in order to get 0, only the numerator needs to equal 0. It's undefined. Yes, correct. Good job. So it's really just this, and then you're going to solve that, get your critical point, make sure it's a minimum, or the location of a minimum. You would add 24, divide by 8, so we get t is 3. I'll go ahead and tell you that is the answer, but if you're being extra thorough, the way that you check that that actually is the location of a minimum instead of a maximum is you would take that 8t minus 24, make a number line out of it, and I'll go ahead and tell you it changes from negative to positive, which means minimum. Maximum would be positive to negative. So if this question said maximum, they wouldn't make that a free response, because then the explanation becomes real difficult to write out, because you don't get an answer, right? You would just say none, there isn't one, or no solution, I guess. I've never seen them do that. Sometimes you'll get 2 critical points. One will be where there's a minimum and one will be where there's a maximum. You have to test to see which one's your answer. But I've never seen them ask, like, put maximum here and then not get an answer. I've never seen them do that. So they're evil, but they're not that evil. All right. Particle moves so that blah, blah, blah. What did they give us? Velocity. All right, so just be aware of what they gave you. If position, velocity, acceleration, just make sure you realize which one they gave you. So they gave us x prime and they gave us y prime. Is the particle moving left or right when t is 3, up or down when t is 3? So left and right is x, up and down is y. We're going to plug 3 into our velocity and see what we get. So if you plug 3 in there, you just get 2e to the third, which I don't know exactly what that is off the top of my head, but I know that it is positive. That's the point. So left or right? Right. Good job. Negative would be left. All right, and then we're going to do y prime of 3. So velocity at 3 for y. Plugging 3 into there, you would get 1 minus 5/4. 3 plus 1 is 4 is all the math we did there. Now, is that positive or negative? I would think of 1 as 4/4. So 4/4 minus 5/4 is going to be negative. So up or down? Down. So x is left to right, y is up and down. Just make sure you use velocity. If you weren't given velocity, if you were given position, what would you have to do? Drive. Okay, cool. This is the one that I messed up. Our initial condition is at the 0.14. So those should actually be parentheses. I'm sorry about that. Do you see the difference? Like, that's where the particle is. Yeah. Okay. So I apologize. Those should be like actual parentheses. So do you see how it says find the position vector? Our answer is going to have the pointy ones. Oh, okay. This is, do you know the question I asked you to skip on the quiz? If you had drawn that graph, the coordinate points are where the particle is at those moments. Those are regular parentheses. Does that make sense? Yeah. Okay. Don't think about it too hard. All right, so we're going to, let's do x first. Initial condition for x is 1 plus, now we're not finding at any particular moment. We just want the position vector. So we're going to go from 0 to t. Again, it was 0, but do you get that that's this 0 here? Yeah. But it might not be 0. Sometimes it's 12. I don't know, just read the problem. All right, and then what was our velocity for x? 2e to the t. dt. Oh, you know what? I should make that a different letter of the alphabet. We already used t, so technically this should be x. Do you get what I'm saying? Like, t is in the boundary, so technically that should be a... If you wrote t, I would never mark it wrong. Okay. It can't be the same. Yeah, it implies that they are the same variable. It's kind of like having 2 children and naming them both Bob. Like, do you know what I'm saying? They're not the same, yeah. I wouldn't mark it wrong at that point. As long as your answer... You guys are thinking way too hard about it. They should technically be different, but it's okay. Like, let's try to move forward. All right, your antiderivative of 2e to the x is 2e to the x such that 0 to t. See, because if I made them both t, when we do the upper boundary, you would be plugging t in for t. If you ever do that, that's where you should be like, oh, wait, these shouldn't be the same letter. You should never plug t in for t. Like, anyway, technicality. All right, so we're going to do upper minus lower. So it'll be 2e to the t minus, this one's not 0. E to the 0 is 1 times 2 is 2. Okay? So this comes out to 2e to the t minus 1. We're going to do it again now because parametric equations have 2 of them. There's an x and a y. All right, but it's going to be the exact same process. You're just going to use all the information for y. So what was our initial condition? 4 plus integral 0 to t of 1 minus 5 over, technically it should be x plus 1 and then dx. Or technically you could use any letter of the alphabet you want besides t. I would just go with x. That's easiest. All right, antiderivative of just plain 1 is x. Now, ignore this 1 for a second and pretend the 5 was just a 1. Just pretend. Use your imagination. What's your antiderivative for 1 over x? It's ln. And then put those numbers back. It'll be minus 5 ln x plus 1. If it wasn't just x plus 1, if it was like 9x plus 1, you would need to throw a 1/9 out front. Your u substitution. I know, everybody's tired, like leave us one. Such that 0 to t. All right, so we're going to do upper minus lower. I'm actually going to use parentheses for this one because it's a little bit more complicated. All right, if you plug in t, it will be t minus 5 ln t plus. You're basically just recopying all that stuff with a t in it instead of an x. Minus, oh wait, it's going to just be 0, isn't it? Well, x is 0. You can't ln 0. There's an asymptote there. But 0 plus 1 is 1, and ln of 1 is 0. So actually that whole thing does end up being 0. The 4 is the initial condition. That's not part of the upper minus lower. All right, now we're writing our position vector. So it's r of t equals, and here's where you use the like pointy brackets. So it's this thing, comma, this thing. And then you feel like mic drop at the end, kind of like made it through. All right, and then the last one, acceleration vector. Acceleration is derivative of what? Velocity. And I think they gave us velocity, right? Yes, okay, so just do the derivative of what they gave us. Derivative of 2e to the t. 2e to the t, that's an easy one. And then derivative of this. Well, derivative of 1 is gone. I'm going to just cover that up. I'm going to do a margin problem. I would rewrite this off to the side as -5 and then t plus 1 to the what? Yeah, -1. And again, if you're able to hold that in your mind, cool. I just wrote it off to the side. Either way is fine. So we're going to do the derivative of that. You would bring the -1 down. Negatives cancel, so it's a +5. And then this drops to -2. So when I write it in my answer, when I come back from my like margin problem there, it's going to be 5 over t plus 1 squared. Good job. Oh, I'll still say this on the recording because I have a couple people that aren't here that I know are going to watch it. Your delta math is all calculator. So they're not going to ask for like a velocity vector. They're going to ask for a velocity vector at t equals something, and you're going to use Desmos. They will have you round to 3 places. They don't truncate, they round, and it will mark it wrong if it's not correct to 3 decimal points. So you get a red X, come up to me immediately because chances are good you just rounded wrong or something, okay? But it is all calculator. So we friends with Desmos? We shall see.